Physics is a huge subject. It explains everything from galaxies at the edge of the universe to tiny subatomic particles deep inside atoms. But if you're new to physics, it can feel confusing. How are all these topics connected? So today, I'll try to show you that connection. This is the map of physics. All of physics can be divided into three main parts: classical physics, quantum physics, relativity. Let's start where physics truly took place. Classical physics. Start with Isaac Newton theories. Newton's laws of motion, which is describe how objects move. His law of universal gravitation connected falling objects on Earth with the motion of planets in space using one simple idea. Another branch of classical physics is optics, the study of light and how it travels through materials. This explains prisms, lenses, telescopes, microscopes, and cameras. Telescopes open the door to astrophysics and cosmology, allowing us to study stars, galaxies, and the universe itself. Light behaves like a wave, and wave theory explains about reflection, refraction, and diffraction. This leads us to electromagnetism. James Clerk Maxwell physics showed that electricity and magnetism are two sides of the same thing. He proved that light is an electromagnetic wave, and electromagnetism explains all of electricity we use today. Classical mechanics studies of fluid. Mechanics explains how liquids and gases flow, from airplane lift to car aerodynamics. Because fluids involve trillions of tiny particles, their behavior can become unpredictable, leading to chaos theory, where tiny changes create huge differences in outcomes. Thermodynamics is the study of energy, how it moves, changes form. By the year 1900, classical physics made the universe look like a machine, predictable, precise, and deterministic. But cracks began to appear. Some things didn't fit, like Mercury's orbit and strange behaviors of light. That's when Albert Einstein changed everything. Special relativity says the speed of light is constant, which means time slows down at high speeds. It also gives us the famous equation, E equals mc squared, showing energy and matter are the same thing. General relativity says gravity isn't a force. It's the bending of space-time by massive objects. Relativity explains the very big. Like, speed of light constant, which explains light speed, is always the same for everyone. Time dilation. Fast motion makes time slow down. Length contraction. Fast motion makes objects look shorter. Space-time tell us space and time are connected like one fabric. Gravity as curved space-time tell us how gravity happens because space-time bends. Relativity explains space-time and gravity. Quantum explains particles and probabilities. Both must merge to describe black holes and the Big Bang. Quantum physics explains the very small. Atoms were once thought to be tiny solid balls, but quantum theory revealed electrons as wave-like patterns existing in energy levels. Condensed matter physics studies many atoms together and gave us modern technology like computers, lasers, semiconductors, and quantum devices. Nuclear physics explains radiation, nuclear power, and fusion inside the sun. Particle physics goes deeper, discovering fundamental particles described by the Standard Model. Quantum field theory combines quantum physics with special relativity, and it's our best theory so far. All our physics explains only about 5% of reality. The rest is still a mystery. Big questions like, what is reality made of? Why does the universe exist? Do we have free will? Does science reveal ultimate truth? This is it. Let's end this video here.